Hi there, this is Alex from Knowm Inc. and this video is to help you set up the Memristor Discovery platform, get all the software installed, get the analog discovery working, get it calibrated, test in your Memristor Discovery board to make sure it's all functional, and finally to make sure that you have functioning Memristor chips. So to get started, we're going to need the Memristor Discovery version 1 board. That's available on the Knowm Inc. web store. You're also going to need the Analog Discovery from Digilent, Analog Discovery 2. That's also available on the web store. You will need the wire dongle thingy that goes with the Analog Discovery. This should come with the Analog Discovery kit. You're going to need the micro USB cable. This also comes with the kit, but I just note that you're going to want to apply the magnetic choke, or also called a ferrite choke. This will reduce high frequency noise. It's helpful in triggering on fast pulses. And finally, in order to calibrate the Analog Discovery, you're going to need a voltmeter. We're going to use this to test the arbitrary waveform generators and verify that the oscilloscopes are all functioning. Okay, without further ado, let's get started. Okay, so now we have to install the software for Memristor Discovery and the Analog Discovery, and we have to get them talking to each other. If you're skilled in this martial arts of software installation, I would recommend you start simply by going to github.com Knowm Memristor Discovery, as you can see up here in the title bar, and check out the README. So everything I'm getting ready to show you is all available on the README, and you could shut me up and just get right to work by following that. Otherwise, I'm going to guide you through some of the process and point out just a few things to keep in mind if you're having any issues. Okay, so first we have to install the waveform software that comes with the Analog Discovery. So you're going to want to go to the Digilent store website, store.digilentinc.com, and click on Software, and you should find a link to the waveforms software. You want to pick your operating system, download it, and when you do, you're going to be greeted with an installation program of some sort. It's really going to be dependent upon your operating system. So what I'm showing you here is for Mac, but it's different for Windows. It's different for Linux. So if you have something other than a Mac, look in the README, look at the instructions, and it'll guide you through. So from Digilent, we're installing 3 pieces of software. There's the waveform software. This is sort of a modular general software for controlling the Analog Discovery. It's pretty cool. You should check it out. I'm impressed. Then there's also an FTDI driver that's needed to get the Analog Discovery to talk to your computer. And finally, there's an SDK. We need the SDK in order to interact with the Memristor Discovery software, which is in Java. One thing to note is that if you get everything installed, booted up, and the waveforms software is not recognizing the Analog Discovery, that's likely due to the fact you haven't restarted your computer, and when you do, the FTDI driver is going to take effect. And if it doesn't, then maybe you didn't install the FTDI driver. Finally, we're going to install the Memristor Discovery software itself. Hi, Future Alex here. Ever since we've released version 0.0.7, this comes with an installer with Java already built in, so no need to install Java. Simply download the executable for Windows 10 or the diskimage.dmg file for Mac. Double-click and go through the normal processes that you do for installing a program on Windows or on a Mac. You should be good to go. On the other hand, if you're installing for Linux and or you're building from the source code and you want to run it from the jar file, then follow all the instructions that I'm about to give you now. It's a Java program, so first thing that you have to do, if you don't already have it on your system, is install Java. In the README file, there is different ways of doing it depending on your operating system, so it'll guide you through that. You can just read that here. Now, once you've installed Java, you're going to want to go to the releases pages in Memristor Discovery on our GitHub. project, and it'll give you the latest release. So you're going to want to click on the latest jar release, and let's save that to the desktop. I've already downloaded it because I've done this before, but it will show up here. Okay, so we have downloaded the waveform software. We have downloaded the SDK. We've downloaded the FTDI driver. We've installed all these things. We've installed Java, and we've downloaded the Memristor Discovery jar. We are now ready to plug the system in, boot it up, and get started on calibration. So next up, we need to plug in the analog discovery, make sure the waveform software is working and that we can control it. We're going to test both arbitrary waveform generators and oscilloscopes. So if you can't get past this step, you're going to want to go back and check to make sure your installation was successful. Okay, so we're going to open up waveform software, and what I want you to do is go to the wave generators. So click on wave gen, and we're going to configure wave generator 1 to be a sine wave. So click run, get that going. Okay, we're going to go back, and we're going to actually do another wave generator, wave generator 2, and we're going to set that to a square wave just to differentiate it whenever we measure. So we're going to click run. So right now the waveform generators are going. We're going to go back to our scope and get that going. Okay, so our scope is currently reading nothing, which makes sense because nothing is connected. You're going to want to use this dongle provided by Digilent and get your Memristor Discovery board. You'll notice there's some pins here on the bottom, and these are useful in situations like this. So what we're going to do is hook up arbitrary waveform generator 1 to oscilloscope 1 and waveform generator 2 to oscilloscope 2 and see if we have a functioning device. Okay, so these orange wires are oscilloscope channel 1. We're going to hook those there. These blue wires are oscilloscope channel 2. The stripe indicates the negative or ground connection. So we're going to put that one there, that one there. Finally, we have the waveform generators, which are these yellow. Waveform generator 1 is solid yellow, whereas the stripe is waveform generator 2. So we're going to hook that waveform generator 1 to there and waveform generator 2 to there. Okay, so it looks like we have ourselves a device. It's functional. We're measuring the square wave on channel 2, and we're measuring the sine wave on channel 1. Notice this interesting RC effect right here. So we have a device, and everything works. So if you hook this up and you don't get this result, keep fiddling with it until you do. Actually play around with the waveform software. It's pretty cool. So now we have to calibrate the device. So get your voltmeter ready, and I will see you in the next section. So open up waveforms. Make sure you have your voltmeter handy and your Memristor Discovery board, as well as the dongle wire thingy, I don't know what it's called, and your analog discovery. Okay, so within waveforms, you're going to want to go to Settings, Device Manager, and make sure you have your device here selected by the serial number. It should automatically select it for you. And then click Calibrate. It's going to give you a list of things that you need to calibrate. We're going to go through waveform generator 1, low gain. You're going to want to do the low gain for waveform generator 1, waveform generator 2, and then test the oscilloscope. The positive and negative supply is really not all that important. So long as it's able to put out about 5 volts, the Memristor Discovery board is going to be just fine. Okay, so let's get started with waveform generator 1. What it's going to do is put a series of voltages. You're going to measure them with the scope and see if everything is congruent. Enter in the offset, and then it should store that on board the analog discovery itself. Okay, so we have our voltmeter, we have our Memristor Discovery, and we're going to use these pins here as a nice place to attach the wires from our dongle. Okay, so it's asking us to measure the voltage on WaveGen 1 and enter the field below. Okay, so WaveGen 1 is this yellow wire. So we're going to put WaveGen 1 over here, and this is in reference to ground, so we'll put that here, and we're going to measure the voltage across those two. So, like so. We're at 2.1 millivolts. So we enter that here. Go to the next. And it's going to ask us again, and we just repeat this process. So I'll try to speed this up, but this is really all we have to do. Okay, so we have calibrated waveform generator 1. Everything was congruent. You notice towards the end it all started to dial itself in. Go ahead and do this for waveform generator 2, and then check out the oscilloscope. When you're done with all of this, just hit apply. Do you want to apply the calibration changes? Yes, we do. At that moment, it's being written into the analog discovery, and we're good to go. So close on out of that, and your device is calibrated. So now we can move on to booting up the Memristor Discovery software and taking our first measurement on a Knowm Memristor. Okay, so we are almost done, I promise. We've tested the analog discovery, we've tested that the waveform generators work, we've calibrated the thing. So now just plug your Memristor Discovery into the analog discovery. Hi, Future Alex here again. As of version 0.0.7, there's no longer the need to go into the terminal in order to launch the Java jar program. This is for Windows 10 or for Mac. You still have to do this for Linux currently. Also, there's no need to specify flags in order to boot into the board check experiment. That is available by default now by just going to the experiments menu. Also, no need to specify the board type flag when booting up. That is available as a menu option under board now. And we're going to boot up the Memristor Discovery software. So we've previously downloaded that jar onto in directory, and I'm going to open up the terminal, and we're going to want to go into that directory, and we're going to launch it by typing java-jar, specify the jar, and then this is the V1 board, so we're going to give it the V1 flag, and in order to test that we have a functional board and that all our equipment is good, you want to specify the test flag. Okay, so Java jar Memristor Discovery V1 test, and get that going. And that's going to launch the Memristor Discovery software. And it's going to boot into the board check experiment. So if we go up here to experiments, we have them all listed out here. This is modular software. You can make your own experiments. And the very first thing that you have to do is to test that your equipment is functional and working as expected. Because if it's not, it doesn't matter what software you write, it won't work. So we're going to test our board, make sure everything's good and within spec, and when it is, then we can move on to our experiments. Okay, so we're in the board check experiment. Notice there are 4 buttons here. One clears this terminal, and then the other one's test for certain things. Okay, so the first thing that we're going to test is the onboard 1.4 muxes, these guys right here. The function of those is to route the waveform generators and oscilloscope to one of 4 different locations on the chip. The A node, the B node, the Y node, and one of the external pins. So the way that we do that, the board is going to just route the waveform generator one place, and it's going to route the oscilloscope to the same place. It's going to apply voltage, see if it matches, and it's going to move on in various combinations. Okay, so everything is plugged in. We're going to hit the mux test, and boom, it's done. We notice that all the different routes are within spec. You know, if this is more than about 2%, then you're going to want to calibrate your analog discovery. Future Alex here. If your 1.4 mux board test has failed, it's very likely due to the fact that this resistor right here is pulling current off of the waveform generators, and basically there's a little voltage drop, and it's causing there to be a little bit more error on the waveform generator to B node route. So just take the resistor out and then run the test again, and you should be good to go. Okay, so our muxes work. Next, we want to test the bilateral switches here on the side. Now these are used to selectively couple memristors from the memristor chips to our driver circuitry. And we're going to test that by putting in a dummy chip here, which has 5 kilo ohm resistors between each of the terminals. I soldered this up by just taking some old headers. I also have another blank here that I just put into a cheap dip socket. It's not necessary that you make one of these, but the test itself is just testing to see that there's a 5 kilo ohm resistor between each one of the terminals. Okay, so we're gonna put that guy in there like that. I'm going to make note of the precision resistor that you have in the second shunt here. Make sure that the jumper is configured as shown. What's going to happen, we're going to apply voltage across the series of one of these resistors selected by the switches in series with the precision resistor here to ground. It's then going to measure the voltage drop. It's going to figure out what the current is, and with that it can figure out what the resistance of this resistor is. It's going to move through every single one, and if it's all roughly equal to 5 kilo ohms, then it passes the test. So we put that in place. We note that this is 15 kilo ohms. Make sure that in your preferences it specifies 15 kilo ohms. And we're going to hit the test. It's going to go through every single one of those. And it measured all of those resistances as being approximately 5 kilo ohms. So we have muxes, we have bilateral switches, they've both passed. And finally, take your Knowm Memristor chip, put that in the socket, and we can test that. So there's this test, the Mem inline chip test, tests specifically for our discrete devices where there's one memristor between each opposing pin on the dip socket. There are other chips out there, and as we add them, we will add tests to the board check experiment here. So we have that in there, and we're going to click the Mem inline chip test. Now it's going through, and first it measures the resistance with all the switches off, make sure that that's very high resistance as it should be, and then it proceeds through all of the different devices, testing to see what the resistance is, then writing the device to a highly conductive state, testing the resistance, and then erasing it, and doing that, seeing if all the transitions match, and if it doesn't, if it fails, it tells you why it failed. So what we see here is that device 6 has failed, and it says Q2 is less than the minimum. So the difference between the conductive and non-conductive state whenever it went from write to erase on that second cycle wasn't good enough, so it failed. And as a consequence of that, it's been categorized as a Tier 2 chip. So on our web store, if you see Tier 1, Tier 2, burn and learn, and you're wondering how we make that determination, it's right here. We plug the chip in, we hit that button, and we do what it tells us. If you'd like more information about the tests that this thing is actually performing, go to Window Help, and it'll bring up the Help menu. You can do this for any of the experiments. So hopefully this all worked for you, and you have a functioning setup. You have Memristor Discovery talking to Analog Discovery. You have working memristors, and now we can get started, and we can actually start experimenting with Knowm memristors.